Good day, guys. My name is Babatunde Bolaji Ade. I'm also known as Mr. Faraday, as my friends and students calls me. I'm a concerned youth who has been a victim of senior secondary external examinations. After many setbacks, I decided to do every possible thing to avoid another reoccurrence. Hence, through months of study and research, I devised methods to bring these courses to its barest level, which of course worked out for me and has helped a lot of my students. Then I thought to myself, how many students out there are like me? How many students out there think physics, chemistry, and mathematics is too hard for them? How many students out there think mathematics is full of calculation, physics is just too complex, and chemistry is too volatile? Will I be able to help if I pass this method across? Then I made a resolve to make short explanatory video sections and put them out. So guys, I'll be making short explanatory videos on chemistry, physics, and mathematics. So help me push the like button and please subscribe so as to get notified when I post another video. The subject we'll be taking a look at today is chemistry, and the topic is electronic configuration. Electronic configuration follows the principle of Hofbauer. So what is Hofbauer principle? Hofbauer principle states that the sublevels with lower energies are filled up before that of higher energy levels. Every law is trying to pass a message across to us. What is Sir Hofbauer trying to pass across to us? 1x, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, and so on. So 1s comes before 2s, 2s comes before 2p, 2p comes before 3s, 3s comes before 3p, 3p comes before 4s, 4s comes before 3d, and so on as the arrow states. Now we have 1s, 2s, 2p, 3s, 3p, 4s, 3d, and so on. So we have the s orbital, the p orbital, the d orbital, and the f orbital. The maximum number of electrons the x orbital can accommodate is 2. The maximum number of electrons the p orbital can accommodate is 6. That of d is 10 and that of f is 14. Now this s, p, d, f orbital are the respective groups we have, are the respective blocks we have in the periodic table. We have 4 blocks in the periodic table. And the blocks are s block, p block, d block, and f block. We have 7 periods in the periodic table. And the periods are period 1, period 2, period 3, period 4, period 5, period 6, and period 7. Now, let's write the electronic configuration for some elements. The first example, boron. Boron has an atomic number of 5. Therefore, 1s2, 2s2, and 2p1, where 2 plus 2 plus 1 is equal to 5. Now let's take another example. Aluminium. Aluminium has an atomic number of 13. Therefore, 1s2, 2s2, 2p6, 3s2, and 3p1, where 2 plus 2 plus 6 plus 2 plus 1 is equal to 13. Now let's take the third example. Silicon. It has an atomic number of 14. Therefore, 1s2, 2s2, 2p6, 3s2, and 3p2, where 2 plus 2 plus 6 plus 2 plus 2 is equal to 14. Now, one of the advantages of the electronic configuration is its ability to help us determine the group, period, and block an element belongs to in the periodic table. So, we have 3 examples here: boron, aluminium, and silicon. Let's determine the blocks boron and aluminium belongs to in the periodic table. Now, boron, 1s2, 2s2, and 2p1. The last orbital here is 2p1. The alphabet here is P. Therefore, boron belongs to block P in the periodic table. Aluminium, 1s2, 2s2, 2p6, 3s2, and 3p1. Let's take a look at the last orbital, 3p1. The alphabet here is P. Therefore, it also belongs to block P in the periodic table. Now, let's take a look at another example. Carbon, 1s2, 2s2, 2p2, where 2 plus 2 plus 2 is equal to 6. The last orbital here is 2p2. And the alphabet here is P. Therefore, carbon belongs to block P in the periodic table. Now, let's take a look at the first element we have in the periodic table, which is hydrogen. It has an atomic number of 1. Therefore, 1s1. The alphabet here is S. Therefore, hydrogen belongs to block S in the periodic table. Don't forget I said we have 4 blocks in the periodic table, which are the X block, the P block, the D block, and the F block. So in the next video, I will teach how to explain the period and group an element belongs to in the periodic table. Don't forget to push the like button and please subscribe if you haven't done that, so as to get notified when I post another video. Thank you.